Well, we're now going to finish the section of power of a power by looking at some more advanced examples that come from the video you just saw a moment ago, that it's on the same page. But we're going to work the examples together, and then you will have time to do a bit of practice. So we're going to begin with this example. And the question is, use the power rule to simplify this expression, which is 5 x exponent 7, all that exponent 4. So remember that when we apply the power rule, we multiply the exponents of each of the terms. So let's take a look at what happens in this case. The exponent for the 5 is 1. It's implied. We know the exponent for the x is 7. So our first step would be to rewrite this as 5 multiply 1 exponent 1 times 4 is 4, and x exponent 7 to the power of 4, exponent 4. And then we are going to apply our power rule. Notice that the exponent 4 applies to both the 5 and the x exponent 7. And we call these, when we apply the exponent to both the number and the variable, we say that we are distributing it. So now that we have identified that, we realize that we can rewrite these as 5 exponent 4, and our power rule states that we can multiply the exponents 7 and 4, arriving at 28. And then our final semi-final expression is 5 to the power of 4, x exponent 28. And of course, we can evaluate 5 to the power of 4 at 625, x power 28. The next example involves division. So in this case, we have a division, a exponent 4 divided by b exponent 5, the whole expression squared. So we are going to repeat the same logic. We're going to apply the power rule to each exponent on both variables. So let's take a look at what we did. We take a exponent 4 and then multiply it by 2 per the power rule. And of course, that square 2 applies also to the b exponent 5. So when we do these, we arrive at b to the exponent of 5 times 2. And when we do our calculations, we realize this is 8. 4 times 2 is 8. So a exponent 8, excuse me, and b exponent 10, because 5 times 2 is 10. So same idea. And then the last one we're going to do is a little bit more sophisticated. It has variables and it has coefficients, a numerator and denominator. One of our coefficients is raised to a power. So this has a lot of little details. But the logic is absolutely the same. The square, or the exponent 2, is distributed to each of these terms, to the 3 square, the 8 exponent 8, to the 4 exponent 1, and to the b exponent 5. So when we apply our power rule to this expression, this is what we have. We had 3 square and we multiply by the 2. So each of these is going to be multiplied by these 2, that is the outside power. The same thing with a. A was to the power of 8 and multiplied by 2. 4 is raised to exponent 1. Multiplied by 2 is 2. And b was exponent 5. Now is b exponent 5 multiplied by 2. And once we do the little calculations, we figure that this is 3 exponent 4, a exponent 16, divided by 4 squared, b exponent 10. And of course, we can do the calculations that 3 exponent 4 is 81, 3 times 3 times 3 times 3, and 4 squared is 16. So this is our final simplification. 81 a exponent 16 divided by 16b exponent 10. And of course, now we're going to do a little bit of practice like we do often. And we're going to do one example together, and then we want you to complete, as always, 5 or 6 on this page. So let's look at our question. Simplify the following expression. Be sure to fully simplify the coefficient by evaluating the power. So let's take a look at what would happen here when we applied our power rule. We have to apply to distribute the exponent 3 both to the f cubed and to the 2 squared. So if we do that, we see that the f and the exponent would be 3 multiplied by 3. That would be 9. So I'm going to write it here, f to the exponent 9. Of course, you might need to be doing this paper and pencil. We're walking through the example here just by voice, but please feel free to grab paper and pencil as you need. And then let's do this that indicates division, this symbol that is in our keyboard. And then we're going to do 2 square cubed. Well, by the power rule, we multiply the exponent. So this would be 2 square multiply the 2 to the power of 2 times 3. So 2 to the power of 6. And 2 to the power of 6 is 64. So then we would write 64 in the denominator to make sure we fully evaluated the coefficient. And let's see if we got it right. Yes, we did. So there it is. And so now you're going to have some fun with this, trying a few more of these examples. And then we're going to go into the big summary here. And our big summary is just elaborating on what we just talked a moment ago. This is our power rule that we've seen before, that we saw in previous sections. When I have a variable raised to a power and then all that raised to an exponent as well, I leave the base the same, multiply the exponents. And then we realize that we can have expressions that involve two or more variables with 2 or more exponents that also are raised to a different exponent. And we just literally distribute these outside exponent, in this case c, to every variable inside. So for example here, x to the exponent a multiplied by y exponent b, all that exponent c, we see that we are taking x and applying power rule. The exponent would be a times c, and y would be exponent b times c. And similarly, this applies also if we have a division. So if we had 8x to the exponent a divided by y exponent b and the whole expression raised to exponent c, we distribute the c to both x to the power of a and y to the power of b. We know they multiply, and we always have to remember that every time we have division, we have to make sure that our denominator never goes to 0. So thank you for watching, and we'll see you soon.